Welcome to this episode. Today, we're diving into something pretty interesting. Why the Biotech International Institute, or BII, builds its research around biological systems instead of making single claims about the brain.
Yeah, it's a great topic. You know, neuroscience gets tossed around a lot in everyday talk. Words like brain repair, neuroplasticity, or cognition get used like they're simple concepts. But really, the brain is way more complex than those terms suggest.
Exactly. People often think of the brain as if it works through just one pathway or mechanism. But BII takes a different approach. They look at the brain as a set of interconnected systems: defense, adaptation, repair, and communication with the body.
Right, and that's important because oversimplifying can lead to misunderstandings about what science actually knows and what it's still figuring out. BII's approach is all about studying these systems carefully before making any claims.
They call it a pathway first and validation first strategy. So instead of jumping to say, this treatment fixes cognition, or this platform repairs the brain, they focus on understanding the biological mechanisms first.
That's a smart move. It's more credible and aligns with how serious scientific research should be done. So maybe we can break down the 4 biological systems BII focuses on? It helps to get a clearer picture.
Sure. First up is defense biology. This is about the brain's immune-related functions, how it responds to stress, injury, inflammation, or infection. Think of it like the brain's emergency response team.
Yeah, like firefighters and paramedics always on alert. The brain has special cells like microglia and astrocytes that act like first responders. They use signaling molecules, cytokines and chemokines, to coordinate the response.
And BII's neuroforal platform is exploring these neuroimmune signaling pathways. But it's still early days. No claims about treatments yet, just research into how these systems work.
That's a good point. It's all about understanding the biology before jumping to conclusions. Then there's adaptation biology, which covers neuroplasticity, the brain's ability to change and reorganize itself.
Neuroplasticity is fascinating because it's linked to learning and recovery, but it's not always positive. Sometimes, the same processes can lead to things like increased pain sensitivity or stress responses.
Exactly. It's like a city's traffic system that can reroute when there's a roadblock. But sometimes those detours cause jams or accidents. So plasticity needs to be studied in context.
BII's Neural Reset platform looks at these adaptive processes, especially related to stress and recovery. Again, it's research stage, focusing on mechanisms and biomarkers.
Then we have repair biology. This is about neurotrophic pathways, signals that help neurons survive, grow, and repair themselves. Molecules like BDNF and NGF are key players here.
Think of this as the city's maintenance crews, fixing roads and infrastructure to keep everything running smoothly. BII's microforal platform investigates these repair signals, but it's still in the research phase.
And finally, brain-body signaling. The brain doesn't work alone. It's constantly communicating with the rest of the body. Pain, stress, sleep, immune activity, and cognition all interact in complex ways.
Yeah, like a feedback loop. Poor sleep can increase pain sensitivity, which can increase stress, and that cycle keeps going. BII's platforms together address these interactions, emphasizing a holistic view.
So it's clear that BII's approach is about looking at the brain as a whole system, not just isolated parts. But how do they actually measure all this complexity?
That's where biomarkers come in. Biomarkers are measurable indicators in the body that tell scientists if a biological pathway is active or a mechanism is working.
Like inflammatory molecules, stress hormones, sleep patterns, or brain imaging results. But no single biomarker tells the whole story. It's the combination that helps build a clearer picture.
This biomarker-guided approach helps turn broad biological questions into testable research programs. It's a way to bring some objectivity to very complex systems.
And it also explains why BII avoids making single claims about treatments or cures. They don't say their platforms treat diseases or improve cognition yet because that requires extensive validation and regulatory approval.
Making premature claims can be risky and damage credibility. Instead, BII focuses on studying mechanisms, measuring pathways, and working toward validation with partners.
Speaking of partners, neuroscience research at this level needs collaboration across many fields. Labs, pharmacology experts, addiction researchers, biomarker specialists, and more.
Right, no one group can do it all. BII plans to work with multiple partners to validate findings and build evidence. It's a team effort.
So to sum up, BII studies the brain's defense, adaptation, repair, and brain-body signaling systems as interconnected parts of a whole. They prioritize understanding mechanisms and validating findings before making any claims.
The brain is like a city with many interdependent systems. Emergency services, traffic flow, maintenance, and communication networks, all working together.
And BII's research is research stage, patent pending, built for validation, emphasizing mechanism first, validation always.
Hopefully, this gives listeners a better sense of why serious neuroscience research requires patience, rigor, and a broad perspective, rather than quick, simplified claims.
Yeah, it's a complex field, and BII's approach respects that complexity. Thanks for joining us today.
Thanks. Talk soon.